the dial indicator is set up on the number 1 piston. It's right here. Right now this dial indicator is set to 0. Piston, I believe, is at top dead center right now, true top dead center, and I'll verify that here. Okay, so what I'm going to do is roll this engine over until my dial indicator here, where I think the piston's at top dead center, I'm going to roll the dial indicator over 50 thousandths to drop the piston down in the hole by 50 thousandths. And then we're going to look at the degree wheel here and see what number we get on either side. It's 10, 20, 30, 40, 50, and I'm going to go past it and run up on it. Okay, so I've dropped the piston down 50 thousandths. You can see I went from the 0. As the piston was going down, it dropped down to the 50 thousandths. And on my wheel, I have about 12 and a half. So now I'm going to bring the piston back up to top dead center, let it rotate over, go back 50 thousandths the other way. All right, so that's 10, 20, 30, 40, 50. And we're back to 0 where I think I'm at true top dead center. So now I'm going to drop it down the other way into the whole 50 thousandths. 40, 50. Okay, that's on 50. So now the piston's down in the whole 50 thousandths again, but the other side of the rotation here. And on my wheel, I've gone to 12. So on either side here, so basically when this dial indicator is at 0, my piston's at true top dead center. If I go down 50 thousandths one direction, I'm hitting 12 on the wheel. If I bring it back up to top dead center and then 50 thousandths the other way, I'm also hitting 12 on the wheel. So that means that right now, if I go back to 0 on my dial indicator, this piston is at true top dead center, and then I can move on to testing the lobe lift and finding the intake center line on this camshaft. So now that I brought the dial indicator back to 0, this piston's at true top dead center, and my degree wheel leaves us with about a degree. So we need to change that and reset this wheel to 0. Because we know our piston's at top dead center, so we want our wheel to show 0. Okay, so right now the wheel's at 0, the indicator's marking 0, and my piston's at top dead center. So now I'm going to relocate this dial indicator over to my number 1 cylinder intake side of the lobe of the camshaft. Okay, so that took me a minute to set up. This piston's still at true top dead center. I'm still 0 on the degree wheel. The camshaft is on the base circle. The indicator is set up to 0. And pretty sure I'm on the intake side of the lobe. So you'd have exhaust and then an intake, and then exhaust and then an intake. But we're looking for the intake center line, so I'm on the intake lobe on the number 1 cylinder. So I've never actually done this part before, but in watching all these videos I've been watching, what they're doing is they're taking the base circle and they are turning the motor over until it comes up to the top of the lobe, and then measuring the distance from the base circle to the top of the lobe and coming up with a lift number. So I'm going to actually try that. I never did that before. So basically what I'm doing is I think I'm down here on the bottom of the lobe. I know I'm down on the bottom of this base lobe of the cam. And I'm going to turn the motor over till it gets to the top, and I'm going to check on my dial indicator what that height of that cam lobe is, and that should tell me to lift. Okay, so right now my camshaft's on the base circle. My dial indicator is set to 0. Okay, so you're going to have the big dial that's going to be the thousandths place, and we're going to have a small dial that's going to be the 100 thousandths. So every full rotation is going to be 100 thousandths. So let's start on the base and turn it. You'll see the big dial move when we start to go up on the base circle, on the to the top of the lobe and off the base circle. Okay, now we're moving up the lobe, headed towards the top of it. There's 100 thousandths. There's 200 thousandths. 300 thousandths, and we should be getting close here. Okay, so there's the end of it. Any more and it's going to head back the other way on the other side of the lobe. So our number is going to be 331 thousandths. Okay, so here's the specs on the full throttle cam that this is supposed to be. It's a 210, 215 duration at 50 thousandths lift. It calls for 516 thousandths of lift, and it installs at 110 degrees. And that's what I'm actually trying to check, is that this thing is at an install of 110 degrees at the lobe center line, or the intake lobe center line. And if it's not, if it comes in at 112 or 108 or 106, then you have to advance to retard it to get it to 110. So that's what we're checking. Now, when I just checked the lobe lift on it, I got to 331 thousandths. And then I'll multiply that by my rock run ratio, which is 1.55. And that gives me 513 thousandths lift. So it calls for 516, and I'm getting 513. I'm going to go ahead and say that's probably accurate, because I'm sure that there's some variance in my measuring. First of all, I'm using a hydraulic lifter instead of a solid lifter. I'm on the base of the lifter, looking for a good place. This is a cheap Summit, thing. There's a lot of variance here. We're talking 2 thousandths between 513, or a couple thousandths between 513 and 516. So I'm sure that that's probably right. Maybe it's off a little bit. Maybe I just caught something. But I don't really think there's anything you can do about that. But I got to move on to this intake center line and try to get that verified. So right now this cam lobe is at the top of the base circle. We know either direction is going to drop it or lower it. So we have to find the center line of this thing, just the same way we did with top dead center. So right now I think I'm at the top of it, so I'm going to zero this. I'm going to go to 50 thousandths either side of it. Okay, there's 50. I have about 151 on the degree wheel. Okay, I just brought it back to 0 and went down the other side of the lobe to 50, and I have 75 on the degree wheel, so I'll mark that. Okay, so I brought the cam to the top of the lobe, and then I went 50 thousandths on either side of it. So basically, I went 50 thousandths here, and I went 50 thousandths here, and I marked it on the degree wheel. So on this side of the degree wheel, I got 151, and this side I got 75. And then what you do is you take 151 and 75 and you add them together, and then you average them. So you divide them by 2 to get an average of 113. So now I'm going to go to my degree wheel and take it to 113, and I'll be at the TDC of that cam lobe. There's 110. There's 113. All right, so that's, now my cam lobe is at the top dead center of the cam lobe. Dial indicator's back to 0 where it belongs. And we know we're right in the middle of the cam lobe. I'm going to go to 50 thousandths on either side of the cam lobe and mark my degree wheel. And then try to average them and see if it brings me to the correct intake center line. Okay, there's 50. And I'm at 150 on the wheel. I'll go back the other way. Okay, now I'm back at 50 on the other side of the lobe, and I have right at 75. All right, so this time I started dead on the cam center of the lobe, and I went 50 thousandths in each direction and marked the wheel. When I did it this time, I got 150 and 75. So I got 150 on one side and 75 on the other. And I added them, divided by 2 to get an average of 112 and a half. That's a problem because we're supposed to be at 110. So we're about 2.5 degrees or 2 degrees away from our target 110 of where the cam manufacturer wants this thing to be installed. Now, I think some of what I did was a little sloppy, so I think I'm going to do it another time just to see if it comes closer to 110, or maybe, we'll see. I'm going to sharpen up this needle and try to get it a little bit more accurate and get a better response here, because I don't feel like taking this back apart, changing anything. Okay, this time I've made my needle a little bit more accurate here on the 113, and that is the top of the base circle again, or the top of the cam lobe again. And my dial indicator is at 0, so I'm going to go 50 thousandths in one direction and mark the wheel. I think we're getting 150, maybe 150 and a half. Now we're on the other side of the lobe at 50 down the other side. Yeah, we're 75 and a half maybe. Unfortunately, that math is exactly the same. Nothing's changed. I'm getting 150 on one side. I'm getting 75 on the other. So I'm adding them together, getting 225, dividing by 2 to get an average of 112.5. We got to do something about that. It's supposed to be 110. Still at top dead center, and the degree wheel is dead at 0 with my pointer a little bit more accurate. So when I remove this degree wheel, I can do what I need to do, and it's still at top dead center. That's not going to change. So when I put the degree wheel back on, I can put it back on at 0, and I should be able to go from there. Okay, so you can see if we turn this one notch over, it's going to be +2. So we'll be advancing at 2 degrees onto the keyway here. Okay, so you can see now I'm still at top dead center. My cam dot is facing down, right where it was before. But now the keyway, the 0 before was on this side of the keyway, and the 0 matched the dot. So it was dot to 0, 0 at the crankshaft keyway. So what I did was I took the crank gear off, advanced it by 2 degrees. Now the 0 is on this side of it, and you have a +2 here that lines up with the dot instead of the 0. So I believe we advanced the cam by 2 degrees because it was retarded by 2 degrees. Hopefully I have that right. I guess we'll find out. Okay, degree wheel's right back on. We're still at the 0 mark on the pointer. So I'm going to start turning this thing over. Figure out where we're at. Okay, right now we're back on the base lobe like we were before. So I'm going to run it up to the max lift here and see if any of that changed. Can't really trust these gauges. It's Comcam's junk. All right, we're going up on the lift. There's 100. There's 200. There's 300. Last time we were at 331. Yep, right back at 331 again. So that means our lift hasn't changed. We're coming up with 513, even though the cam card's saying 516. Not sure there's a damn thing you could do about that. Okay, so now I'm going to zero this out because I know I'm at the top of that cam lobe again. And we're going to try to get to the center of the cam lobe. We're going to find TDC on the cam lobe. So I'll zero this thing because we know we're at the top. If we go either direction, we're going to move down the lobe. Okay, that's zeroed. So we have to do the 50 thousandths before and after the lobe deal, and then average them and find the center. Okay, we got 149 on the degree wheel. I'm going to mark that on the board. Show you in a second. Okay, I just marked 149 because that's what's on the degree wheel right now. Where 50 thousandths on one side of the lobe. Now we're going to go to the other side of the lobe, 50 thousandths. Okay, it's about 73. I'm going to write that on the board. Okay, so we basically determined our center point. It wasn't a complete TDC, or true TDC, but we went 50 thousandths on either side and got 149 on the wheel, 73 on the other side of the wheel over here, and then we added them together and averaged them by dividing by 2 to get an average of 111. So basically 111 is where I'm going to set the degree wheel, and that's going to be the true top dead center of that lobe. Okay, so now we're at 111 on the degree wheel. We're back at 0 on this because we're at the top of the lobe, but we are right now dead set, smack dab in the center of that cam lobe. So now I'm going to do 50 thousandths in either direction and split that in half to find this intake center line and see if it's better. Okay, it's at 50. And on the degree wheel, we have 148, between 148 and 149. Let's roll with it. Let's do 148 and a half. Okay, I wrote down 148 and a half. We'll bring it back and go the other way. And back to the top of the lobe, and now I'm coming back down the other way. I'm going past it and then running up on the 50 thousandths to get it, to deal with the slop in the chain, which there's not a lot of, but this is the way to do it. Okay, that's 50 now, the other side of the lobe. And I'm coming up with 73. So I'm going to mark 73 on the board over here. Okay, so this is the math from after I centered my top dead center of this lobe. So on the first go around, we could have been maybe a degree off over here. And that's the math up here, 149 and 73. So we went to 50, we went to 50. We could have been a little off. And that's why we got 149. When I averaged them together at 111 and reset the degree wheel dead to the center of this lobe, I was able to start the process from there and go 50 and get 148 and a half on the degree wheel. Come back here to 0 and go 50 this way and get 73 on the degree wheel. So 148 and a half and 73. And then I add them together, divide by 2 to split them in half. But the math that I got was 110.75. Previously, we had 112, so we were 2 degrees off. Now, this CAN card calls for 110. So we are now at 110 3/4 of a degree. You might not hear a lot of excitement in my voice. That's just pretty common for me, but I'm really excited that making that change to that crankshaft gear brought me back down to the lobe center line it's supposed to be, the intake center line. So this was a victory. One thing I'll say is, I don't know if this is a teaching lesson for anybody, because I don't consider myself much of a teacher when it comes to this kind of stuff. But I did want to just document my journey, and maybe somebody can take away some parts of this and say, okay, well, that was the part I needed help clearing up. I watched 7 other videos, and in those videos, they didn't point this one part out. Maybe I was able to point that one part out that can help somebody go forward. Because there's no one video that helped me figure this out. There's probably at least 10. And I took a piece of every one of those videos and put them together to really try to understand this. So now my cam is degreed in pretty darn close to the cam card, what it calls for. So now I can proceed here and get my timing cover on, check the camshaft end play, and start dealing with this oil pump in the timing cover. Here it is over here. This is just one thing I'm not comfortable with. So I ordered a wear plate from Melling, which I know is not the best one, but I don't know where there's any other options. I wasn't able to find any. But I'm going to put a plate in here and then check that and get my gears to ride on a nice smooth plate instead of this worn pocket where the clearance could be off on the gears, or you could be losing pressure through those scoring. So we'll deal with that next, but right now we have to celebrate this victory. We have a degreed camshaft. Thanks for watching.